Hello, hello first welcome to the screen. Today, today we are going to visit the nearby star systems. Hello first welcome to the screen. Star systems such
Today we are going to visit the nearby star systems.
such as Alpha Centauri,
Nearby star systems. Today we are going to visit the nearby star systems.
such as Alpha Centauri. Alpha Centauri star system, Sirius star system, and the planets and so on. So for beginners, let's say which are the nearest star systems to Earth. So at the beginning, the closest star to the sun, to the sun or the Earth is the Proxima Centauri. Proxima Centauri is smaller than the sun. It is 4.4 light years, about 4 light years away from the sun. So first, as it is the closest neighbor to our solar system, we are going to visit it first. So first, let's experience a beautiful sunrise on our Earth. Great, that's enough. Now we are going to leave our home star system and move towards Proxima Centauri. Yeah, as you can see, Proxima Centauri is red dwarf star, which is smaller than our sun, and its distance is to 4.21 light years away now. And Proxima Centauri is in a binary, triple star system with Alpha Centauri, and one more star. Proxima Centauri is a red dwarf star, which means it has a temperature range below 4000 to 2000 degrees Celsius, so it appears in the red spectrum. As a red spectrum means it is close to the infrared stars, and Proxima Centauri has, I think so, 2 planets. Orbit. So it's see, there are the 3 stars. This is Proxima Davis. This is the planet, I think so, closest to the star system. Yes, so Proxima Davis. Okay. Its gravity is almost half of the Earth. So for make the stream interesting, you'll see a sunrise in the Proxima Centauri star system. So I think that this planet has too much of iron and dust inside it. This planet doesn't seem to have an atmosphere. It doesn't seem to have a big atmosphere, so you can't clearly see the sun. Go to the second planet in the Proxima Centauri Proxima system. And planet is its name is Proxima P. Proxima object. The same as the Proxima D star, just its mass is 1.4 times mass of Earth. It's bigger than the Earth. Its temperature is 30,000 degrees Kelvin. It is not in the habitable zone of the system, so we can't see any life on this planet. So as for a possibility of life on this planet, it's almost looking like a Mars. Big Mars. Okay, here's there one more. Okay, one more. Proxima C. Go to object. Okay, this is also an rocky planet. Its semi-major its temperature. Discovery method. This was discovered in 2019. It is so small, far away from this parent star. So how do we discover planets? Is basically when see, if I am standing over here, and this is our telescope looking at the Proxima Centauri. If the planet passes from in front of us, it will block some of the sunlight from its planet. So we will see a dip in the luminosity of the star, so we can determine a planet has crossed the system. So this is basically a way to search for planets and measure mostly radial orbital speed, etc. Now let's head towards the Alpha Centauri. Center of the sun. So we will just zoom out from Proxima Centauri star. Okay, this is Alpha Centauri. It is okay. Alpha Centauri. It is a yellow dwarf binary, means it has mass similar to the sun, almost close, means it is about similar to the sun. So it is called a yellow dwarf star. It is in a binary system. See, as I have told, the Alpha Centauri system was a binary system. So basically, there is very little possibility of planets that can be capable of giving life. As okay, let's speed up a little, accelerate time. So when the two stars rotate like this, any planet orbiting them will be flinged away from each other. So there is basically no possibility of any planet staying in orbit with them. Yeah, they are orbiting each other. And basically Proxima Centauri also orbits two of them, but it is far away from them. And at a period of time they will come closer to the Earth with less than 4 light years away, means basically at the speed which are now we will take at least 40,000 years to reach them. Now let's go to the next star system, which is closer to the sun. The solar systems which can be counted as a stars, means not brown dwarfs, of course. There is the Sirius star near us, but it is also a binary system. So we'll go in the way of by the distance. So this star system is 4.37 light years away. This is the Alpha Centauri's triple star system. While the Proxima Centauri, which is only I think so 4.2 light years away from Earth. Then next in this list will be Barnard star or something. Yes, Barnard star. So for Barnard star, I think I can't find it by visible way because it is a brown dwarf. Search for it. Let me just check the spelling. Barnard. Okay, Barnard star. So we are traveling at this. This star is basically a massive Jupiter. Basically, it means it is a Jupiter that is so used that its insides have. In the core of the star there is nuclear fusion going on, but it is impossible for that, and it is so little that it is impossible for the energy or light to escape the surface. So its temperature is basically means below the point where it can be visible. It gives off infrared rays, which means it can only be found by infrared telescopes. For visible spectrum range, it is very difficult to find a star. So let's it seems to have a planet in its orbit. Okay, single planet. And Barnard star would be, its mass is 3 times of that due to the oxygen. Oh, it's okay. Number object. Where are the rings? Yes. See how great it is. Here, this star, you can clearly see. Solar day, it has 13 hours rotation period of it. It basically on this gas giant planet. A day lasts for 13 hours means you'll obviously, if you could possibly land on this planet, you could feel your 1 day on the earth will be 2 days here. See how and you can also see these rings. It's basically like a mini Saturn. So we'll see a sunrise from here. Fast, slow down. Space is a very beautiful thing. If you really like space, you can buy this software and space engine or so called at $569. Yes, it's obviously it's $5. Indian currency it is 569 rupees. You can also see everything. It is basically as minimized size, means it is not minimized, but version which is very close to the real universe, very close. So today our third target is we are going to visit the Luhman 16. It is also sometimes called as WISE 1049 star. It is at least 6.5 light years away. Luhman star L16. Okay, we can't even see it. Wait a second, frame drop. Sorry for the interruption, but Luhman star is also a brown dwarf like the Barnard star, but it is very smaller than that. See, you can't even see anything coming out of it. Its luminosity is so less that unless you watch it on the infrared spectrum, you can't even find where it is. also has 2 planets. One is Mars. It is. We will directly land on it. Okay. So this is also a brown dwarf. No, it isn't. It is a binary star. Okay. So I was saying why couldn't I find it? So this is Barnard star system. Luhman star system is a binary star system with 2 brown dwarfs revolving around each other. Means this was basically a star system where it failed to become a main sequence star or even a red dwarf because its mass means that mass was divided into two objects. One, this is Barnard's Luhman 16A and Luhman 16B. Wait a second, we'll see Luhman 16B in a second. Okay, Luhman 16B, where are you? Okay. So Luhman 16B, so they both become a brown dwarf star in space. Oh, it also has aurora. See. Okay, we'll see it. Aurora visible from space. So they both of this is a result of a failed star formation of a failed star system. The mass is 26 mass and Jupiter's and 35. So even if they both combine, they won't become a star. It will become a second Barnard star. So next on this list is stars called Wolf 359, which is similarly, I think so. Yeah, it is 8 light years away. Wolf 359. Wolf 359. Okay, it is also a red dwarf. It is a red dwarf star, not a brown dwarf. A red dwarf star is a star which can basically release luminosity, means heat, but it is still not a life forming star because red dwarf stars are so unstable that they give off a very high amount of solar radiations. Okay, it has a planet of parts of Neptune class. Okay, fire on the dark side. It also has aurora. Now again we are glitched inside it. So this is the Wolf 359. So it is basically a red dwarf star. Now let's go to a true sequence star, which is you can also see the known as the brightest star in the night sky. Cyrus A. Good. Why is this down? This is a white main sequence star, means here temperatures range from 6000 degrees Celsius to 10,000 degrees Celsius. Means basically at this point it is not basically a white, but it gives us a bluish light, but it looks like white from the point of view. It also has a second it is also a binary star system, but it is not binary orbit. They are not in binary orbit with the real star, but also you call it as a white dwarf star. White dwarf star. Okay, yeah, it is. So white dwarf star means it is. There were basically at means in past or something. This white dwarf star, which is known as Cyrus B or Canis Majoris B, was a star, but its age came and it was like a sun. Like a sun will disappear and turn into a white dwarf. It turn into a white dwarf. Means basically it is a dying star. So here also life is basically impossible in this type of star systems, as binary star systems cannot make a planet orbit stably to them. So next on this list we will take so as basically the closest star means which were between 10. There may be many of them like black brown dwarfs and some of them, but basically this was the only stars which are in the 10 light year radius of the sun. So let's get back to the sun. So we'll see from Cyrus star where is the sun. Sun should be this is Alpha Centauri. Okay, Alpha Centauri. Sun should be something around. Can we find our sun? Oh my god. Then what is this star? Canis Majoris, not Alpha Centauri. Very big blunder. So this is the sun. Then there should be Alpha Centauri somewhere here. Okay, we will travel at a speed of 1 light year per second. Okay, this is Alpha Centauri. Yes. Let's go down little. About 10 light years per second. Here we are back at the sun, and I think that should be enough for today. In the next stream, we will try to go to some nebulas near us or anything, something like that. So let's go to the sun first. Okay, we are on the sun. Where is the Earth? Turn on this orbit. We don't need it. This is Jupiter? I think no. Oh, reality. Let's go. And we are back. Okay. We are back home. Blue water. Shining sun in the sky. Let's go make a sunset. We will go to sleep. Oh, Aurora. So guys, that was all for today. If you want to see more videos like this, please subscribe to our channel and turn on the bell notification. If you can, please support like this channel so I can get me some motivation for it. I see you tomorrow.